So if your rainforests are dying, things like that today, your oxygen levels, 21.3% in the air. 21.3% of the air we breathe is O2. And you know what? This is finely tuned. This 0.3, if it was up to I've heard of 0.5, 2 points up or down, either way, either everything would burn or nothing would burn. So what I want to stress in this little example here, photosynthesis, 21% of our air that we breathe now is O2, which they say at a certain time earlier in the Earth's history that wasn't the case, and I believe it, that the Earth had to go through some changes to make it habitable for us before God let us come live here. So what is in the air now? N2, there's a triple bond. 78% of the air that you breathe right now is nitrogen. And it's two of them. So N2 is an N triple bond. And the way you'll really draw this is having electron pairs, because you always got to count the electron pairs. So the triangle really has a little pair of electrons there. The bottom of the clubs has little electrons there. But we're just dealing with bonding here. This is the whole key that no one talks about when they're teaching chemistry. This is the different view. Why I tell you, if you learn it this way, you're learning the bonding. If you got the bonding down, counting the electrons, all that other stuff, you'll be able to look up on a table that they'll give you. But this is what you have to learn. The octets are all 8s, but since we're bonding here with our triangles, watch what happens. One nitrogen's a triangle. It's got 3 bonds. Another triangle with 3 bonds. What do you get? Something that looks kind of artistic, huh? Isn't that one of those 3-dimensional kind of deals? Is this frontwards or backwards? We'll put the N here. Nitrogen, nitrogen, N2. So with this triple bond, we need nitrogen in our amino acids. How do we get it? There's a little bit of NO that's created when lightning strikes, because remember, you've got 78% of the air here that we're breathing is almost totally inert. So think of all the breathing you do, taking a deep breath. 8/10 roughly of that is nitrogen, N2 with a triple bond. So what do you think it does when it goes into your lungs? Nothing. Doesn't react at all. What your lungs are trying to do is get the O2 in and the CO2 out. So this kind of insulates it, that things don't instantaneously combust. So our shapes that I'm promoting here, what's going to be cool for nitrogen is we've got our old amino acid backbone. Remember that. We've got a nitrogen that is bound to a carbon. Carbon's always a diamond. That's what's so great about this. Carbon technically should be black. That's why I don't like the suit thing working with that. So carbon, 4 bonds. What do we know that it's bound to another carbon that gets the double bonded oxygen on it? So let's throw 2 bonds down here to oxygen. That now, this is a cool one we just came up with. It's going to be the quarter moon. So say oxygen out here is quarter moon, but we can dot in the rest of the moon. So double bonded O to the carbon. We've got one more bond up here. Well, where does that go? See, this is the repeating session of the, right here, N. Now what's neat is N's got a little double bond thing here. So I'm going to show you this just because it's artistic. We're trying to make it art, right? So here is nitrogen would technically be the diamond and a lone pair of electrons up there. Makes it kind of like a little alien spaceship, doesn't it? So that's what nitrogen is. Nitrogen, let's say ammonia is NH3. Write that here. NH3 is ammonia. So we could call him the ammonia alien. It's got 3 bonds. What are hydrogens here? They're little dots. So we'll draw a dot, and a dot, and a dot. Now this is really what the chemical structure looks like for ammonia. 3 hydrogens that are protons are out there bonded in a lone pair of electrons. But see, back to our shapes here now too. We know that nitrogen's got 3 bonds. So the carbon here is 1 bond. This nitrogen is what's going to be over here. So I guess we could draw that one in. A triangle. See, we're not even going to draw the N or be thinking anything. We're just on a triangle. And it's a line to it. And you know what this actually gets up there? A dot. So, see the repeating sessions now? This middle carbon, though, this is the one where you're learning your chemistry. This is so cool because this holds the amino acid out there. And it's going to usually hold it by another carbon. So you're going to have a carbon-carbon. Call it a diamond-diamond bond. And when you see it on a test, the D, diamond, will remind you of double. No, that'll just confuse you. Strike that from the record. Okay. And up here. Triangle, there's only one more it can do. You need a carbon's going to be a diamond. Now this amino acid you get to see is going to be hanging off here. This goes to the diamond with the oxygen. That's going to be, we can do this any way we want it. That's the great part of making this up. So let's just say we end the thing here with an oxygen. Make it a circle. Make it a circle with 2 things coming off it. And then to finish this off, because what do we got? A diamond with 1, 2, 3 bonds. How do you give it a 4th? You got this carbon, 1, 2, 3. How do you give that a 4th? So see, what's neat is you see the hydrogens are crisscrossing up and down on the opposite sides. You've got your double bonded oxygen here. But technically, you know me, I'd love to be drawing the electrons out there, but it's not important in this case. I'll actually admit it. So this is free to twist. That's why you can tell which way this goes. And this is what the amino acid backbone is, by shapes. So see how easy these shapes are to use? We'll check this out. Now that we know these, we're going to take all this down. We're going to draw DNA. That's what we've been heading for. We want to draw the coolest, most up-to-date, hardest stuff there is. If we're going to learn science, it's going to be hard. Let's learn the hard stuff. Why waste our time suffering and hating it and struggling with it when all you do is end up with a 3rd-grade education anyway? Okay? The whole thing of chemistry is DNA. So first, I'm going to show you the bases. Each of these bases has their own shapes. There's 2 big double ring bases, and then there's 2 single ring bases. There's a 3rd one, they call it RNA, DNA, but we're going to compare them. So the big double ringers, we're going to do now with diamonds and triangles. Now this is what's so neat, is because you've got a nitrogen here. Nitrogen triangle, only got 3 bonds. Well, this out here is going to the sugar. So it's only one way it can go now. And we know it's not nitrogen to nitrogen, so it's got to go to a carbon. It's going to be a triangle up here. Try and keep that thick. Triangle. This triangle goes up to a diamond goes to a triangle. Triangle goes to diamond. Now see, I'm no brainiac, but I can draw the DNA chemical structure just knowing that there's a nitrogen in a 5-membered ring and they're not touching, so there's no other way this could be. So this has to be right. You're going to have a nitrogen to a carbon to a nitrogen to a carbon-carbon, and then back around on the nitrogen. So these are little tricks you can teach yourself, and now it's just a matter of, since the carbon-nitrogen bonds are in, just fill the ones with the dot. Look at that, dot, dot. I'm getting dot happy. I better watch out. See? Yep, I'm too dot happy. This actually has a double bond to it. So if I'd have been paying attention, drew my triangle the other way. So the second part of this double ring structure over here goes to a diamond. This goes to a triangle. There's nitrogen. This diamond goes to a triangle.